Morning, everyone. Hey, that was good. The coffee's kicking in. I guess it does that at 10:30. Thanks for the warm welcome. So it's great to be here today. It's a little surreal for me, actually. I was up in Seattle yesterday at about 5 o'clock giving a presentation at a Microsoft conference called Build. Jumped on a plane, and here I am in San Francisco at a Red Hat conference. So it's kind of a fun experience. It's great to have you here in the room. We hope to give you a breadth of content across security and management of Linux virtual machines in Azure over the course of the time. Honestly, I have too many slides, so we're going to go really fast past them, and including not talking to quite a few. And we'll show you demos of Azure and what Azure can do for you in helping securing and managing your Linux workloads. Just some real quick setters. You know, our approach in Azure is to be cloud for all. We have some real Linux data afterwards, but Linux is a very, very significant workload for us on Azure in terms of existing customer usage. And when you use your Linux, you can use it in up to 50 regions. Our approach here in Azure is to build data centers that are close to where the customer is. It's becoming almost impossible to put that on a map, and particularly in Europe, in an easy-to-read way. But at this point, we have 50 different regions with hundreds of data centers that support 140 countries worldwide. So we have global reach. And by the way, last time I updated that slide about 6 months ago, it was 40 regions. So we're certainly not stopping in terms of our data center build-out. In terms of customer usage of Linux on Azure, there's tons of customer usage. Here's some of the case studies that we could drill into. But just to really frame it for real for you, of all of the virtual machines running on Azure today, more than 40% are running on Linux. Okay? So it's not a sideshow for us. More than 40% of those virtual machines are Linux virtual machines. And when you think about new virtual machines, it's actually more than 1 in 2 are being created on Linux. Okay? So Linux is growing faster than Windows. Am I allowed to say that? I guess I am here, right? On Azure, and is already at 40%. We expect at some point it will cross the 50% barrier. Okay? So there'll be more than half the virtual machines on Azure running on Linux. And we don't think that spot is far away, certainly not more than 12 months, probably less. When we look at the marketplace solutions, these are pre-packaged partner solutions that would have a Linux OS with agents, daemons, software in it. About 60% of those are, in fact, Linux-based. So customers are taking it seriously. We're taking it seriously. It is a very, very important workload in terms of Azure and the success of Azure. Do not be confused. With respect to Red Hat in particular, I want to bring up this quote. This is customer Smithfield's. They're effectively in the meat production business. They moved to Azure and chose Azure as opposed to Amazon based on the partnership that we have. We have a great partnership with Red Hat, which we'll get into a little bit later, but support is one of the key things they highlight, and of course, the product does what you'd expect is another key aspect. Here's another customer, CREA, also expressing how important it was for them to get to market quickly. And so the combined benefit of Azure with the support for not just Linux, but open source technologies in general was compelling for this customer as they move forward. And while I continue my very quick diatribe on how important open source is for us at Microsoft and Linux, if I didn't already convince you, Microsoft, in fact, has the most GitHub contributors in the open source land, the second most projects. The co-creator of Kubernetes is actually a development manager for the underlying deployment stuff in Azure. ARM is the templating process we use for creating resources, and also the Azure Container Service, which would make sense if you were the co-creator of Kubernetes, wouldn't it? Microsoft is, of course, a member of any number of foundations in the Linux space, from the Linux Foundation to Apache and so on. And then the executive vice president of Apache is also on the Azure Compute team. So there's a lot of internal expertise at Microsoft, which 17 years ago when I started, I wouldn't have put a slide up like this. It would have been a really odd conversation, wouldn't it? but times have dramatically changed. In terms of Azure, from a technology choice perspective, you have incredible technology choice. Obviously, from a distro perspective, and I have a slide that will talk more about that, of course, Red Hat, 6, 7, anything, 7.4, whatever you like, 7.4s are the latest, right, guys, is an important piece of that. But then whether it's your favorite database or your favorite app framework or your favorite application on top of that, your favorite management stack on top of that, or DevOps, all of these are options for you to use. Many of these you'll find in the marketplace and get started and use. I'm going to spend time talking to you about the Microsoft-provided management and security tools. You can choose our tools that are built into the platform. You can choose these tools. You can choose a combination of both. It's entirely up to you. All of these things are supported. When it comes to Red Hat specifically, what's the advantage of Microsoft and Azure in particular in Red Hat? Well, we've a fairly unique agreement and partnership with Red Hat that provides joint engineering as well as, from your perspective, great support. So in terms of support issue resolution, I think you'll find it second to none in terms of the work that we do with Red Hat to support you running on the Azure infrastructure. Of course, you can bring your own license to Azure and go ahead and use it. And then, as I mentioned, unlike Amazon, although they're building up a portfolio, our approach in Azure was that we could put security and management technologies deeply into the platform in a much more solution-oriented, holistic way, as opposed to kind of bits and pieces, which is Amazon's current approach. And so there's a number of things that you won't find in Amazon, like backup, for example, like security that looks inside the Linux virtual machine, like disaster recovery, like cost management, I could go on, that are built into the Azure platform. So with that, I'm going to bounce backwards and forwards with Juan, who is my technical guy, although I'll drive one of the demos.
Hello.
And so I'll introduce Juan to quickly show you how you get Linux up and running on Azure.
Sounds good. Thank you, Scott. Hey, everyone. I'm Juan. I'm the technical product manager for Azure Security and Management. And can I see a show of hands who have actually seen the Azure portal before? All right. So that's probably even more than half of you guys. That's great. So as you can, for those of you who haven't used Azure before, this is the portal that you can actually go and customize yourself. And basically, some of the interesting information or the relevant information that you see with the resources that's running on top of Azure and for some of the resources that's running on premises, you can actually pull them up and have Azure portal leverage as your common dashboard that you can share with your peers or any of those people who would probably be relevant to the views that you have set up. So, but today, here, when you set up some of the, when you want to spin up a few resources in this Azure portal, you can obviously hit this icon right here and basically create a computing node of Red Hat, most common 7.2 version for for my view. However, today, I like to leverage something called Cloud Shell. Is there anybody who actually used Cloud Shell before? All right, great. So that's a few of you. Right, so Cloud Shell is an environment for all Azure customers who can basically spin up a Bash or a PowerShell environment, a CLI environment, on top of that browser. So all you need is a 443 port open to leverage this Cloud Shell. And what you can do is basically it's going to authenticate behind the scenes for you, along with the authentication that you may have used of accessing your Azure environment. So here, as an example, I want to probably create a VM, but before I do that, I'll probably list out some of the VM images that we have. So these would be providing some of the common images. So let's say that I want to create some Red Hat images. I would probably go VM create, but I want to get some help out of this. Commandlet in here, I can see, all right, so I'll leverage the last example right here, which is create, and I'll say Red Hat VM 0001, just so that I don't have duplicate naming here. And I'll have Red Hat Summit 2018, and I'll use the rel image. So with that, you kind of get the idea. If you're comfortable with Bash and other CLIs, you can basically do this. And you can have multiple other tasks having leveraged this Cloud Shell in any of the browsers. If you are using your mobile, you can definitely use that as well. You can also go into the shell.azure.com/bash, which will direct you to Cloud Shell as a full view. So if you want to access this through mobile, you can do that as well. What I would like to do is come up with a little bit of a more, I wouldn't say complicated, but more of a relevant resources that you can provide to your developers or any type of applications owners. So here I'll say everybody who do use Cloud Shell would be provided with a 5 GB of cloud drive. So I would go into this cloud drive, and I would actually go into one of the shell scripts that I have created, which is basically a multi-tier app that will have a load balancing on top, which it would be a standard environment for most of the applications. So here I will create a resource group, obviously, which is basically how you group the resources, and you could add policy into these resources and so forth. And under that resource group, I like to create a public IP address to be leveraged for my application. And I'll create a load balancer. Hopefully you can see this a little better. Okay, there you go. And once you create your load balancer with your front end and the back end pool, you'll associate your public IP address. Then you'll create a health probe, which it will look at the load balancer and kind of define which ports that it needs to look at and which return, which HTTP response it will be looking at in order for us to define which is healthy or not. And then you'll have the load balancer rule set up. And then you'll create a virtual network that would associate with your virtual machine to leverage that load balancer. So you will create a virtual network, network security group associated with it, and I'll create 3 network interface card with a specific name. And then finally, I'll go ahead and create a virtual machine that has this availability set and associate this load balancer and so forth. Here I used Ubuntu, but you can obviously use the Red Hat images as well. So I have pre-run this prior to the event. So actually, I'm going to go ahead and look at some of the network public IP address and show so that I don't forget. Summit is 2. Sorry. Is 2. And my public IP. And here, this is the the previously created virtual machine associated with the load balancer and the network cards. And here I see the public IP address. So if I go ahead and access this, this public IP address, it will either go into VM 1, 2, or 3, right? So you can try it on your mobile phone right now, so that we'll have more interesting monitoring data throughout later at the session. But you'll see that I'm accessing this website through VM 2 with the load balancer up front when accessing it. The interesting thing that I wanted to show was with these VMs that you have created, we are able to, so here we're accessing VM 2, so I'll go ahead and access Red Hat VM 2 in a serial console view, which means that even if you do not have the accessibility to this machine because of any network card that you have misconfigured or so forth, you can even access it as a console mode here. This was kind of the most asked feature from our customer support internally, and we have provided to you guys as a public preview a couple of months back. And what this will do is it will give you a console view of the machine. Then you will log in, and you can basically figure out what the issue is, even if you don't have the network connectivity. So while we do that, what I can do, as you can see here, we have Ubuntu Advantage support. We have a Red Hat support in here as well. As what has Scott mentioned earlier, if you have the Red Hat Enterprise license, then you can actually associate that support that you would have. And within the actual experience, you'll be able to directly link to the Red Hat support, which will give you direct support from Red Hat. And here, I am accessing this machine through console. Hopefully. All right. And, whoops. I will probably fail because I did not write the right login info. And if I log in, what I will probably do is reboot, just for the fun of it. All right? So here you can basically see from a console view that the system is being rebooted. And if you refresh, you'll see that it's directly going to access to VM3 instead of VM2. So the actual app is actually working. So with that, I'll share back to Scott. However, what you have just seen is basically provisioning an Azure with multi-tier app. You have the load balancer up front with a simple shell script, and you can just deploy it and provide that access point to your developers, and you basically have that infrastructure on top of your hands. Right?
And we expected you wanted to see a scripting experience, but of course you can point and click on the portal and go choose file, new image, and as any selection from the marketplace, and off you go as well. It's super easy if you want to use the portal. Many people script for scale. In terms of distros that are supported, I'm not going to spend a ton of time here. I will say that the publisher of all of these distros is the Linux partner. So Microsoft does nothing other than put them up on the marketplace. There's no hidden Microsoft code hanging around in any of these Linux images. And our focus in working with partners has been on production workloads that you would use in production. You can bring any DIY hobby level Linux distros you want to Azure. They'll run. But these are the ones that we focused on to make available in the marketplace for you and work. Cool. So great. You've got Linux up and running on Azure and you're done, right? Well, honestly, whether you're running it in your own data center, whether you're running it on Amazon, or whether you're running it on Azure, you aren't done. And sadly, I'm still educating people on that in some cases. When you put things in Azure, our commitment is to ensure that we provide the security and the management capabilities at the physical layer. Okay, we make sure that the data center is well built, has the right biometric controls to let people in, has just in time, just enough access for our own administrators when and only they need it. We also have built-in denial of service to make sure that as a platform you don't get in a denial of service place. So there's absolutely lots of things we do. Of course, we do all the hardware maintenance upgrades, the networking, blah 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 blah. We do all of that. However, as soon as you put just one virtual machine or even one PaaS service on a cloud, any cloud, including Azure, there is work that you should be doing, as well as us, to ensure that that is secure and well managed. And so in Azure, recognizing that, we have built a set of tooling into Azure itself, which we think simplifies that. By kind of blurring the line between what used to be standalone security or standalone management products and cloud platform. We're a cloud platform that has security and management built into it, while also, once again, embracing anything else you want to use. This is all totally up to you. So what have we done, and what's our overall approach? So the built-in services that you can use with Azure span a fairly wide life cycle of services. From an IT perspective, we do not do service management, ticketing systems, ITSM, stuff that ServiceNow, Cherwell, Provence do as examples. That's not something that we're building into the platform. But outside of that, there is a lot of management and security capabilities across the full life cycle here. So if you want to do security both in protection and mitigating threats, we've got it built into the platform. If you want to back up your data, it's built into the platform. If you want your apps to continue running, even if a data center, either your on-premises data center or even an Azure data center, goes down, not that it's ever a goal for us, we have that capability. In monitoring, if you want to monitor apps, you want to monitor virtual machines, you want to monitor collections of virtual, we can do that too. And so on, including cost management and policy. So there's this full breadth of SaaS services at your beck and call that you can use to more quickly than before really go ahead and secure and manage your Linux resources. So let's look at security quickly, and then I'll go into a quick demo of Azure Security Center, which is one of the key pieces. So from a security perspective in Azure, obviously, security is just not a single thing. You need to think of security in multiple layers. You need to think about security in terms of access control. You need to think about security at the data level, encryption, both on disk or increasingly in flight with confidential computing and SGX and that type of stuff coming in. You obviously need to think about network security groups, and beyond. You need to think about security management. Security management is getting visibility into the state of all of your assets and understanding, like, am I good? Or are there best practices that I'm not following that I really need to follow to be protected? And because fundamentally any security approach is flawed if you stop at protection, we recommend you have a defense in depth approach that is not just protect, but also check to see when the ever-evolving bad guy is out there and going after you. And so that's threat protection, where you're proactively looking at your workloads and understanding, are you being attacked, are you being compromised, and if so, obviously mitigating that super quickly. So with that, let me jump out of slides and head over here. Okay, cool. So Security Center lives here as a left-hand shield in Azure. In our limited time frame, I've opened a few things just to accelerate it. Security Center gives you security visibility across compute, networking, storage, and applications. I'm just going to show compute really quickly. In networking, you can look at things like your VMs in network security groups or not. Here I have some virtual machines. Here's 3 Linux virtual machines. These virtual machines, this one doesn't yet, but these virtual machines have an agent on them. This agent you can find on GitHub. It's called the OMS agent. It's built on top of FluentD. It picks up audit logs and a variety of other inputs. It's used for both the monitoring stuff, which Juan will show later, as well as the security stuff. So this agent runs in an extension against your virtual machine and pulls data. And one of the pieces of data it pulls is, are you missing system updates? Do you have the latest patches on or not? And then what vulnerabilities do you have? And do you have disk encryption on? And so you can see here, actually I'm good, I've got the right system updates on here. This one's telling me it doesn't know because I haven't installed the agent. And so I need to go ahead and install that agent, and then the Christmas tree lights will light up in whatever colors are appropriate. So if I go across here and clicked in that line and off to the right, then I get a more detailed view of a single virtual machine. And I'll get you back there in a second. There we go. And so this particular virtual machine, which is Contoso Azure Linux 2, here you can see it is being monitored, but it does have some serious issues. It's missing disk encryption, and it has 2 security configuration issues. I can also click into those and go into a log analytics view if I wish. So the advantage of this piece of security management is that, one, I can understand the state of my virtual machines in this case, but also networks and also storage accounts, etc. And then go ahead and address issues and protect. And this capability is free, aka if you're an Azure user, please go in here. The first time you go to Security Center, it will ask you if you want to enable data collection. What enabling data collection will do is install the agent in the VMs that you have on Azure and start firing off data so that you can get this rich view for absolutely no incremental dollars. Okay, it's a fundamental part of the platform. It's also, I think, quite differentiating relative to Amazon, who's started to play here, but with GuardDuty does not have the ability to look into virtual machines. They do not have an agent. And so they can't tell what's going wrong within virtual machines, whereas with Azure we can. So that's the, very quickly, a skate on the surface on the protection piece. Actually, if I just go one other place on protection. One of the bigger issues in terms of threats and protecting from threats that exist out there is, let's see if I can find one that's not configured. I'm not sure whether this will work. I should have checked to see whether this one will work, but we'll see. Is the fact that in many cases you have to open ports, management ports on virtual machines to do remote management. You want to SSH into your VM to go ahead and fix issues that are in it. And so what often people do is open up those ports, port 22, to the internet. And if you open up port 22 to the internet in a virtual machine in your data center, in my data center, or anywhere else, it's going to get tickled. It's going to get tickled up to 100,000 times a month for people trying to brute force your passwords, okay? Because they know that once they own that one virtual machine that's attached to the internet, then they can attack deeper and deeper into the center of your organization. So that's not a fun situation to be in. So what we did here was kind of turn the paradigm on its head, which is rather than having the management ports open the whole time, let's shut them the whole time and create an approval workflow so that, and this one's already set up, well, I'll set up in a second, and create an approval workflow so that when somebody comes in, the port gets opened. So in this case, it's a Linux VM. I don't need 3389. That's Windows stuff. And so I will turn that off. I do need port 22, so I'll turn that on. So I would go and add and discard things from here. Press OK. At that point, once that virtual machine is set up, it now has its management ports closed. They are no longer open until someone comes in here and does the following. I'd like to have access to this virtual machine. I want access to port 22. I just want it from my desktop or an IP range, your choice, where you specify. And I only need it for an hour. Go ahead and open the ports. And so at this point, that virtual machine ports, if I have permissions, I'm automatically provisioned. I'm not sure whether I have permissions to that virtual machine. It would appear here if I do. I'm automatically provisioned, and yep, there we go. And I go ahead and access that virtual machine for my management job, and an hour later the ports are closed. And the likelihood of you being attacked on the internet through your management ports goes down dramatically. And it is probably the #1 attack we see on Azure, is people using weak passwords and those passwords being caught. And honestly, it's a bad day for us when you get owned by a botnet, and it's a bad day for you. So this is paid functionality. I would recommend you use it, as is what I'm going to show you moving further forward. Cool. So then the next place I'll go is you've protected all you can. What about the threat aspect? Well, we have the ability using the Microsoft Security Graph that is informed by all of our anti-malware stuff, all of our antivirus that's running on Windows computers, all of our cybersecurity stuff, all of the knowledge we know of people attacking our own data center. We have this just massive data source. And we use that data source against your assets to understand security issues. So you can see here I have a pretty noisy account. Looks like I've got a bunch of only medium severity issues, which is good, not critical. Often I have critical severity issues going on in my demo accounts. And so you can see here I have a long list of issues because I have a mix of Windows and non-Windows computers in here. There is a variety of different things. But if I go over to remediate security configurations, which is that very bottom one, just to show you a Linux example, here you can see, and once again, this is not the world's most challenging issues. If you would be an SSH brute forced, that would be up on the top of the list of issues, and you would see it here. But here you can see that we're recommending turning off RDS because, as you know, RDS has had some issues in the past with vulnerabilities, and if you're not using it, turn the thing off. Or we're showing that this particular Linux VM could be used as a sniffer, or file permissions look wrong on these syslogs, and so you should really set those to 640, and they aren't currently set that way. And so there's examples of issues that need to be fixed. As I say, the more common one, which I didn't demo today, but I should have, is the SSH brute force, in which case you'd go on in and obviously take that VM offline, go ahead and reset the password at a minimum, and potentially pull it back up. So I'm flying crazy fast, but there's Security Center. If you're an Azure customer, please turn it on. It's good for you and it's good for me. I recommend you turn on the JIT stuff, which is paid, and the threat stuff as well. Of course, as I said before, there's a wide range of partners that we work with in the security space. Some of these plug straight into Security Center. And so, for instance, Qualys can be triggered directly from Security Center in terms of vulnerability assessment. And so it's not just looking for Microsoft antivirus, for example. on your virtual machines, it's looking for a variety of partner antivirus, and then it pops the partner antivirus up. Not every partner on that list is up in Security Center yet, but all of those partners run on Azure. Okay, so we're going to do backup next, and I guess we're going to now really start flying, if I'm not already. Are you guys keeping up with the speed of my delivery? Yep, I'm doing okay? Great. So to back up a virtual machine in Azure is really simple. Unlike Windows, Linux doesn't have volume shadow copy, and so you want to run a prescript and a postscript on databases and the like to make sure your database is in a good, consistent state before you do that. And to quickly show you how simple backup is to run in Azure, let's get one on stage again to go through it.
Sure. So this is going to be really quick, so I hope that you kind of can follow through what I'll be doing here. So in terms of backup, we have a virtual machine here listed, some of the virtual machines that we have just created earlier. And as you can see, we have a number of management capabilities that is actually embedded to our virtual machines management capabilities. And here you can see that backup, you can click on it and basically simply just back up without any of the infrastructure in place. Oh, sorry about that.
Thank you.
Thanks for that.
I'll get PowerPoint out of presentation mode.
Yep. There you go. All right. So here on the virtual machines, you'll see that the operations are listed here as well as monitoring. And these are the management capabilities that you can basically perform right out of the box. And here, if you select backup, you can either create a new recovery vault, which is a place for you to set up all your policies. And for instance, if you have a tier 1 backup policies in place, you can apply that. Here, I'll just use one of the existing ones. And I'll apply a default policies, which basically you can also configure and alternate between, all right, so what's the retention period, and how often do you want to perform these backup performances and so forth, and you can just enable it. And just out of the box, as you can see, you can perform within the GUI, and as you might have guessed, you can actually perform all of these through the Cloud Shell Bash interface as well. And you can also recover it from the Cloud Bash or the GUI as well. So here, as an example, this is going into one of the recovery services vault, which has all the backup items and also the policies. You can see that there are some of the machines that has been backed up, and you can just easily go ahead and recover based on the recovery point. If you were catchy enough on the Principle 2 slide that you had, there were some flows and steps that you can perform to actually maintain your application consistency. Let's say that if you are running MySQL, you want to make sure when you are recovering, you want to make sure that the application was consistent when you recover along with the data set that it had been backed up with. So those are all in place, built in, and we are aware of those applications that to make sure that the data set of files are associated with a certain application, and we'll make sure that that is in place when you do recover from the backed up instances. So here are the backed up items. One of the things that I do want to call out is that in order for you to delete any of the backed up policies, you can actually perform it with an elevated security element, which is a multi-factor authentication. So whenever you want to delete the file, which most likely or not the sophisticated ransomware does these days, they track down which backup processes that your virtual machine or your machine uses, and it will actually kill the process, and they will delete those backed up items so that you won't have the chance to recover from that scenario. And here, in order for you to do that, you'll actually need to configure a multi-factor authentication. Well, I'll take that back. You need to perform a multi-factor authentication in order for you to delete the backed up data. And here, with a simple configuration, you're pretty much set up. And you can't even delete, even if you have multi-factor authentication set up, if you do not generate a PIN, which will only be available for the 5 minutes time frame if you have created this generate security PIN number. So we're pretty much safe in terms of ransomware to making sure that even if any of your backup processes are exposed, we'll make sure that we retain those backed up servers because we provide these multi-factor authentication out of the box. So with that, I'll hand it back to you, Scott.
Cool.
Yep.
And just maybe, I know we're flying now, but maybe one more point there is you can restore your whole VM, or we can iSCSI mount it in Azure, and you can pull out a single file. So if just my MySQL records got destroyed, I can just pull that one file back and off I go. And yes, if you want to use any other partner solutions, you're absolutely welcome to use those in Azure. I will say that as of today, roughly a third of all of the virtual machines in Azure are backed up with Azure Backup because of how easy it is to use, how economical it is to use. And there's no infrastructure required for you to use Azure Backup. You don't need another Red Hat virtual machine running a vendor product. You don't need to update it. We do all of that stuff directly. Many people use those products, of course, to back up their existing on-premises environment into Azure, which is great. Okay, cool. So monitoring. Obviously, applications need to work, and when things go wrong, that's a problem, and so you need monitoring. The monitoring capabilities that we have in Azure are really broad. And so one's going to just take you through, I think, log analytics and app insights. But fundamentally, you can get the basics, obviously, of CPU health and disk health and network health on a single virtual machine, of course. You can understand the interrelationship between multiple virtual machines in real time. We have a network sniffer that figures out that this Red Hat, you have a 3-tier architecture, and you have this Red Hat web server connected to this Red Hat app server connected to this MySQL database. We can figure out in real time the interrelation of those things. So if you miss the piece of paper that someone who is the developer once wrote that had the architecture, and you're in the middle of a troubleshooting session, you know for real, because we sniff the network, which machine is attached to which. So if there's a problem on the back end MySQL server, that is reflecting back onto the PHP web server, then you can see that quickly. And then we also have the ability to dive into code. And so you can write, for example, Java code or in any language that imports an SDK, which will then spit out, if you like, performance and profiling information back to Azure. And so you can use this in live site issues to determine a particular line of code that's causing an issue. And you can also use this from a functional perspective to understand which pages your customers are using more than other pages. So maybe those are the ones that you spend more time investing in to make the performance better, or maybe those are the ones you add more features to versus those that are not, based on this SDK that is sending information out. So with that, let me hand it back to Juan.
Sure. Thank you. All right. Hopefully I did exit it successfully this time. All right. So one of the simple examples that I can share with you is how you enable those application insight as an application owner when you provision your machines. And here, the method that we took was cloud init. Hopefully this will spin back up. All right. So I'll go to the cloud drive again, and basically, Cloud Init is, if you guys know what Cloud Init does, right? For Ubuntu and Red Hat and for most servers, it's an execution when you launch the actual machine. You'll go through this automation and configuration process. And here, as an example, what we did was have an app insight running, and you have the keys here. I just put it in here, but if you can kind of hide it with your keys, you can obviously do that as well. Here, you basically just enroll your application to those, and this is just a simple Node.js, and it will automatically push out all the relevant data to the application insights view that we provide as part of Azure services. So here, with that, how does it show within the actual environment? So one of the sample applications that we have, you can see that how this application is performing, and you can also, as part of the application-centric view, you can map between how it's relevant to that application of how these resources are being used. Here we have a web instance that is actually using multiple different services and from multiple different blob storages or databases as part of here. You can see SQL services. So if there's any issues, you can basically track down. Here we see an instance here that probably may be causing a delay issue, 87 milliseconds, for calling this website, which has taken over 66 6.7% of the time. You can go ahead and troubleshoot based on how it's being connected. So if there are much more complex applications, this will certainly provide a really simple view for you to go ahead and look into how dependent others are. If you want to look a little bit more deeper in terms of performance, you can basically do that with all the data telemetries that we have collected. And you can see that we'll give you some of the good, reasonable amount of data out of the snapshot where, hey, you know what, when you were calling this index, it was causing 1.44 seconds of it. And the top 3 dependencies, which basically is calling out that when this delay happens, these are the common properties that you can go ahead and look at. And I see that Azure Blob is the most causing these issues as you move forward. And as part of failures, if you want to troubleshoot a failure and basically provide those information back to your application owner, you can basically do that with this failure incidents. We'll collect all of the failured tasks here, and you can select one of the 500 error codes that we have gathered, and we'll suggest you, hey, this is one of the incident that may well represent the failure task. And once you go into it, it'll give you some good streamline of the sequence that this user has performed, and you create a work item, and then you can create a GitHub or a Visual Studio team tasks for that application owner to go ahead and look into the data and kind of give you the latest status report on how this bug or this issue is being performed. And one of the last things I wanted to call out was you can see all of these views and pin them down into your dashboard. So if I'm an application owner for a Contoso Retail web app, these are the views that you can immediately see. So not drilling into the actual services, you can basically have a good view as part of this dashboard, which you can share with your teammates. So with that, I'll probably share back.
Cool.
Scott, yeah.
Yeah, and by the way, just actually go back there just for a second.
Yeah, sure.
So as I said before, there's the basic compute view. Are your VMs running efficiently or not? Are they using too much CPU or not? Of course, we have that type of stuff. We have a container monitoring view, which, who went to the keynote? Some of that stuff came out, and disks. Oh, I guess I'm in a different conference. That's pretty funny. Okay, cool. So then let me go back to here, and we'll close up in the last couple of minutes with one more thing. I apologize for the overwhelming amount of information here. I'm just trying to give you a view of the capabilities that we have. Okay, so the last one that we wanted to hit on, actually, you know what, before I do this, I just want to make one statement. When it comes to customers using Linux, and also, by the way, Windows, on Azure, not every customer is using security, is using backup, and is using monitoring for their production environments. We strongly recommend that you do. Whether or not you use the built-in tools that we just showed you, you should have security on them, and not just anti-malware. You should have cloud workload protection and threat protection. You've got to have backup on there, because there have been times that Scott Guthrie, for those who know who he is, has been called by customers and said, hey, I just lost my data. Like, did you have a backup? We do take 3 copies of all your data on Azure, because we have it on 3 different disks, just in case one of the disks fails. So we do take 3 copies, but if you delete a MySQL record from a MySQL table, it deletes it in 3 different copies. If you want a snapshot, please snapshot. And as I say, about a third of our customers are doing that, but the number of production virtual machines is higher. So one takeaway might be, if you're an existing Azure customer, do I have security on? Do I have backup on? Do I have monitoring on? Microsoft supplied or third party on all of my production environment? That's kind of important. And then there's a broader thing I just wanted to finish on, which was cost management. Obviously, in this world of cloud, where you pay for what you use, which is great, understanding what I'm using and whether I'm being efficient in that usage, and then also thinking about things like enabling chargebacks to other parts of my organization are a more interesting topic than they are in a licensing world where the transaction is what it is, often way before you deploy it. And so in Azure, we actually acquired a company called Cloudin, that supports cost management, not just of Azure, but also of Amazon and Google, and enables you to monitor the real-time data coming off your subscription in Azure and model cost against it to either optimize your spend or drive organizational accountability, or both. So in the last minute or so, I'm not going to demo it? Okay. Apparently, I'm not going to demo it. I don't know why. I reckon I can, though. Let me see what happens when I try. I'm going to go to here and do cost plus billing. Oh, sorry. It's billing plus cost management. There we go. So if you go in here, and then you go choose cost management, then at the moment this is in a separate portal because it's a company that we purchased. However, over time it will be deeply integrated in Azure. Oh, and actually this one's not set up. Yeah. But you'll get the idea just from the screen. So for instance, here is the, you can set in your own budget and the cost that you have over time. These go too fast for presentation purposes. You can do split up in departments. One of the cool things that you can do is in Azure we have this notion of a reserved instance. You guys know what a reserved instance is? Yeah. So it's basically buying compute in advance at a discounted rate. And so if you have a workload that's running on Azure for 6 months, you can either pay as you go, which is totally fine by us, or you can buy that 6 months of compute in advance. And the economics might make sense to buy that compute in advance or not, depending on the duration that workload is running. And so in here, you can look at your workloads that have been running and figure out which ones of them actually make sense to drop down to the discounted rate of a reserved instance versus pay-as-you-go, in his example. And then a second example would be just simply looking at the virtual machines that you have over time and figuring out which ones are at the 75 to 100% CPU utilization all the time. You probably want to upsize those. But the corollary would be which ones are only using 0 to 25% of the CPU. You may have purchased too big a virtual machine, and you may want to consider downsizing that virtual machine to a smaller virtual machine. And so what we actually find is customers who use this free tool tend to optimize their spend, reduce their spend with Microsoft in the first 3 to 6 months. And then you have that available cash, if you like, to go use in your budget on other cloud projects. And so we often see lots of customers understanding I'm really in control of my costs now. I have strong confidence that Microsoft's literally giving me the opportunity to pay for what I use and optimizing on it and then accelerating their spend. So cost management's great. There's all types of spreadsheet stuff that you can export out to departments if you own central IT and you need to cost manage out to departments as well, or for accountability. So that's the cost management stuff. So with that, you have just suffered through, experienced, or enjoyed one of those three things. A speedy whirlwind tour of scratching the surface of the technology that we have in Azure for managing Red Hat and Linux virtual machines. I will also tell you that most of this technology, with the exception of the governance technology, works great for on-premises. So you can secure, backup, monitor Red Hat virtual machines on your data center using the same tooling that is in Azure as well. Okay, so we're truly hybrid. We go ahead and install those agents on premises. Those agents put the information in the Azure system, and you use all the Azure user experience. But you can visualize on premises as well as in the cloud information when you do that. And that's not kind of an add-on thing. That's what we've been doing for the longest period of time, given our long history in on-premises management with System Center and other things. So with that, thank you. All questions, more than welcome. Feel free to come up and say hi. And have a great conference. Thank you. Thank you.
So I have a few questions.
Okay.
So you are integrating the questions specific to the cost management.
Mm-hmm.
So I have Red Hat enterprise license.
Mm-hmm.
I think it integrates seamlessly to that. So can you elaborate on the support structure? Because if you have a mission critical system on production,
Mm-hmm.
There's something wrong. You want to, of course, we are Azure subscribers.
Mm-hmm.
So we don't want to point to this is a Red Hat issue. So kind of Red Hat or Azure. So how does the support model work? It's integrated, or we have to call them and then ask them or join them?
Do you want to get it? But it's integrated, and we have a clearly defined
so in terms of
process.
support, you will get the exact same. So how it's done is internally, we have a Red Hat experts from Red Hat, actually stationed in our customer support, so we'll get the direct channel from Red Hat, and if there needs to be a whole different customer support from Red Hat, it will kind of link their resources to that department. However, the experience from a customer standpoint, it will all be from Azure, although we'll weave in the Red Hat support to the customers. And we'll obviously associate the Red Hat support licenses, if you already have them, a part of that support.
The next question I have is on the identity and security management. So most of our companies, we have a single sign-on.
Mhm.
Right. So people have a single sign-on and then try to integrate with the security. And how does this work with the Azure and Red Hat? So because you have when you get only access to this side of the thing, you don't want them to access all of the things. So how does this I single sign-on any tools integrated into this particular?
Yeah, so I think we can take that offline, but in terms of, there's a difference between the guest single sign-on and the actual, the services sign-on. In terms of the Red Hat single sign-on, if there is an Active Directory federation that is being performed by the enterprise, we can definitely pull that Active Directory information up to the cloud as well with Azure AD, and that's how we can perform the single sign-on with Red Hat as well. We do have an example of that. I can definitely share you more details. Yeah, on that as well.
One more question. So you were talking about the patching side of things. You are citing the awareness and your awareness is going to install agents on this one?
Yeah, so there isn't, so it will be easier for you to think about like Azure extension rather than OMS agent. It's pretty much the same thing, but it's an extension that we can enable in the Azure virtual machine that will act as a monitoring and management agent that will do the monitoring of CPU and what's not, and also it will do sort of change tracking and update patching as well. If it's a virtual machine that is living on Azure. If it's a VM or a resource that's living on premises, then we will deploy the OMS agent, which the official name is Microsoft Monitoring Agent. And that will actually, when you install those agents, you obviously have to associate the right set of Azure subscription to the Azure environment that you would have.